In the last video, we have seen the turn-on characteristics of SCR. So, we applied a pulse gate voltage. This is VG. When we apply a pulse, the gate current slowly increases and finally it reaches its steady state value IG. Then based on the value of IG, we have drawn the value of IA, because when it reaches 90%, IA slowly rises. This is 10% of IA or 0.1 IA, and slowly it increases. There is a 90% of IA, and finally the steady state value of IA. So this is anode current IA. So when it reaches its 100% value, we say that the device is turned on. Now for the anode voltage also, when it slowly increases, anode voltage slowly starts to fall. When it reaches its 90% value, anode voltage almost decays to zero, and this is turn on. This is anode voltage and this is anode current, this is gate current. Okay, so during this interval the anode current increases, at the same time anode voltage decreases. So if you plot the power loss, you can see that the power loss is maximum at this switching instant, because the anode current is increasing, voltage is decreasing. So when you multiply, you will get the power loss maximum in this period. Okay, so this is actually the turn on characteristics. Now the turn off. The turn off means anode current should turn to zero value, or anode current should decrease. And what is going to happen in SCR, how much time it will take to turn off. So all those details we'll be learning in turn off characteristics. So the first step is anode current has to decrease. So this is the anode current. Now it is in the full value, it is now flowing. Now the anode current slowly decreases. Anode current slowly decreases and it has reached zero value. So at this instant, the anode current flowing through this device was reached to zero value, which means initially assume that it was flowing at 20 ampere, reduced to 15, 10, 8, 5, 4, 3, 2, 1 and 0. But there are still some charge carriers trapped in these layers. There are holes in P layer, electrons in the N layer. This is holes and electrons in this N layer also. So these charge carriers, these are the trapped charge carriers. So the charge carriers in the outer layer can be easily be removed by connecting an external wire. This can be easily be removed. So the hole moves in this direction, electron moves in this direction. So the current flow will be in this direction. So the current flow will be in this direction means current just start to reverse. So the 90% of the charge carriers is removed from the outer layers after some time. Now there are some still trapped charge carriers inside this layer, junction J2, which can be removed only by using recombination. Okay, so I'm once again drawing the anode voltage. The same graph I am drawing here. The anode voltage slowly decreases and finally it has reached to that value, and the anode voltage stays here. And because of this di by dt characteristics here, that is a change in current with respect to time during the time of recombination, the circuit allows the reverse voltage across this SCR. That reverse voltage is shown here. Okay, due to this reverse voltage, immediately recombination takes place, and due to this recombination finally SCR recovers. Okay, so the time is again divided into two. One time is called TRR, or the reverse recovery time. Another time is called TGR, or gate recovery time. This is the total turn off time, TQ. Okay, once again I am explaining. The anode current should decreases to zero for turn off. But at this instant also you cannot say that SCR has fully turned off. Even if you are supplying a forward voltage, immediately it will go to conduction mode. That's the meaning. So the current should decreases to zero, and after that what is happening? There are some trapped charge carriers in each layer. We have to remove the charge carriers. So the first step is, by themselves these holes and electrons will move out. So the direction of current, the holes direction in this direction, the electrons current direction will be in this direction. So the net direction of current will be in the reverse direction. So the current flowing in the reverse direction. Okay, so the current direction is normally to the opposite to the flow of electrons. So here it is here the current flowing in this direction, so the overall current direction will be in the opposite direction. That's why this negative direction. Okay, and after this time almost 90% of the charge carriers in the external layers are removed. That's why current again decreases. Okay, but there are some still trapped charge carriers inside this layer. It has to be removed by recombination. During recombination, or for the recombination to happen, you have to apply reverse voltage across SCR. But this reverse voltage normally occurs in an SCR because this current, this internal current dI by dt causes a reverse voltage. There are some types of inductive circuits. The SCR or the circuit provide an inductive voltage. You will learn about this inductor characteristics later. For the time being, you need to understand that in a SCR circuit, the circuit itself will provide certain negative voltage, and based on this negative voltage, the inner layer charge carrier is also removed. That is the time for TGR. So TRR is the time. TRR is called reverse recovery time. TGR is called gate recovery time. Reverse recovery time means external charge carriers in the external layers, that is P1 and N2 layers are removed. Gate recovery time is the time required for the charge carriers to remove from the inner layer. The total time is the turn off time TQ. It may take around 3 to 100 microseconds for SCR to turn off. After this time, if you supply any forward voltage, SCR will block the voltage. That's the meaning. Okay, so the conclusion of the switching characteristics is that SCR will not turn on instantaneously. It will take 1 to 4 microseconds to turn on. Similarly, SCR will not turn off immediately. It will take 3 to 100 microseconds. Okay, the total turn on time is divided into 3 intervals: rise times, delay time, rise time and spread time. Similarly, the total turn off time is divided into 2 intervals. One is called TRR, reverse recovery time, and TGR. TRR means outer layers are recovered, TGR means inner layers are recovered. Why this negative voltage appears here and all these things you will learn when you learn about the inductive circuit in the second module.